Good morning, second period class. Glad those of you who were sick are back with us. We still have a few who are out sick with the flu or family issues. We miss you and we hope you're back in class with us real soon. Today we're going to start on chapter 6, section 4. I can solve a system of equations using elimination. Okay? I'm going to try to relate elimination and substitution to make life a little bit easier for you. Either way, these two methods are closely related. So I want us to go over some examples together, and then I'm going to give you an assignment toward the end. Please feel free to participate in discussions because your classmates who are at home watching the video aren't able to ask me questions. You are, and if you're thinking it, they may be too. And you could be their voice for our recording. Alright, solving a system of equations using elimination. Alright, negative 3x plus 4y equals 12, and 3x plus, minus 6y equals 18. All right, let me ask you a question. Does it look like it would be easy to solve this problem using substitution? Not really? Yeah, maybe. Do I have a pair of exact opposites? Negative 3x and 3x are exact opposites. So if I could eliminate those two x's, then I could solve this system for y and substitute to find x, which is what I'm going to do. First off, I'm going to add these two systems together. Since I have an exact pair of opposites, what is negative 3x plus 3x? 0 or 0x. 0 times anything is just 0, so I don't need that. It's gone. 4y minus 6y is negative 2y. And that equals what? Okay? Now what? Can I solve it? Divide both sides by negative 2. And y equals negative 15. Well, that's half of our solution. Y equals negative 15. Now, you can go back to substitution. And here's what I want to do. I want this side of the room to solve the top, use the top equation, solve for x. I want this side of the room to use the bottom equation, solve for x. You're going to be substituting the value, negative 15, for y. Okay? Go. Give you about 20 seconds. Let's see what we get. Love the sound of pencils on the desk in the morning. Makes my day start off so good. You got it? Okay, we got one, got it. Replace y with negative 15. Use this top equation. Write it down over to the side. Instead of y, put negative 15. calculators if you need to. Alright, let's go with this side of the room. What y'all get? Negative 24. What this side of the room get? You messed up. Okay, I'll give you another second or two. Go ahead. You got 36.
I messed that up. That's what I messed up.
You got negative 24?
I got shit.
Alright, so let's look real quick, just to make sure, because I had some folks looking when we got here and they were going, you want me to do what? So let's look at what to do. I asked, on my left, I asked y'all to use the top equation. Negative 3x plus 4y equals 12. Substitute negative 15. Negative 3x minus 60. Y'all double check my calculations. Add 60. We get negative 3x equals 32. Divide by negative 3.
12 plus 60 is 72.
Oh, thank you. And x equals negative 24. Very good. Okay, does that help you on this side of the room? I had a few who were struggling with that. You good? You good?
Can you work out the other equation?
You're not good? Tell me where I lost you. Yeah, we'll work it out. Third line, 1, 2, 3 here. Okay, multiplying these two together, I get negative 60. Okay? Then I have to add that 60 to both sides. Because I'm trying to solve it for x. 12 plus 60 is 72. Somebody corrected it. Bring it down at negative 3. Divide both sides by negative 3. X equals negative 24. Still lost? No. We're good. Alright, and this side of the room, y'all wanted to see yours worked out, okay? You're good? I'm going to work it out because I still see a few faces over here going, huh? Alright, so we got 3x minus 6 times negative 15 equals 18. 3x plus 90 equals 18. Subtracting 90, we get 3x equals what?
Okay, so true.
Okay, got the same thing. Except backwards. X equals negative 24. Okay, so we are in agreement, both sides of the room, that x equals negative 24, and you're correct. Now tell me something. What's that ordered pair right there mean? That's where these two lines, if I graph these lines and I look at them, that's where they intersect, and that is the one solution for this system of equations. That's the one ordered pair that if I replace x and y with these values, makes both ordered pairs true. We good with that? Okay. So elimination is still involving some substitution, right? We still got to substitute even when we eliminate. Let me give you another one. Let's see what you can do. Uh, 4x plus 2y equals 28. And 4x plus, no, not plus, minus 3y equals 18. Do I have an exact pair of opposites?
No.
No, I don't. Can I make an exact pair of opposites?
Yeah.
Multiply what by negative 1? Everything in which one?
Whichever one you want.
Yeah, whichever one you want to. Which one y'all want to multiply by negative 1? Bottom one? Okay. So I'm multiplying everything in the bottom equation by negative 1 because if I want an exact pair of opposites, I've got the exact same thing and I can create exact opposites. So tell me what I get when I multiply. Equals negative 18. Why does it equal negative 18? Yes, I'm multiplying everything in this equation right here by negative 1. Okay, so I'm going to just transfer this top equation. 4x plus 2y equals 28. Do I have an exact pair of opposites? Yeah, I created them. You created them. You helped me create them. So when I start adding these two equations together, what do I get? 0x, which I don't have to put there, equals 5y. I said equals. Now we got equals. 10. Now what? Divide by 5. I eliminated x. I've got y. Solving for y. Dividing by 5 gives me. Again, this side of the room, top equation. Y'all want the top equation? Y'all bunch of whinies. Y'all can have the top equation.
Yeah.
Y'all get the bottom equation. Replace y with 2. Same as what we previously did. Replace y with 2. Solve for x. And we will have our ordered pair that is the solution to this system of equations. You've got 30 seconds or so to do this. Woo. Throw them pencils down. Ooh. Love it. Love it. Ma'am? Okay. So top equation, what did y'all get?
6.
You got 6. Bottom equation, what did you get? 6. So our ordered pair solution for this system of equations is 6, 2. That means what?
That's where the line was.
Yes, if I graph these two equations, that's where the lines intersect. That is the one solution that makes both of these equations tell me the truth. The whole truth and nothing but the truth. Okay? Questions or comments? You got a question, ask it, because remember, your classmates are dependent on you to ask questions for them. Anything? Okay. Let me give you another situation. Huh? I like these too. I've always thought these were so much fun.
I like adding.
Math is more fun than English. Miss Goodwin will spank you for that one.
English is complicated.
Yeah, she's my best subject.
I was 70. I was 76.
All right, shh. Let's talk about math. X plus 2y equals 37. Okay, now what you gonna do?
You put a 1 in front of the Y.
Put a 1 in front of the y. Okay. If you want one,
And then multiply over
I can do that. How am I gonna make exact opposites now?
Multiply everything by negative 2 on the top equation.
Very good. How did you decide to do that?
Because that's a 2, and negative 2 would be the opposite.
Yeah. If I multiply this top equation, like Lily's telling me, if I multiply everything in this top equation by negative 2,
it would turn that into.
I'm gonna get a pair of exact opposites. So y'all help me out with the distributive property here. You know, sometimes I mess it up. What do I get? Not minus negative 2, just minus, yeah. Equals 23?
Negative 46.
Negative 46, how's that?
Because if you multiply negative 2 times 23, it's 46.
Yeah, I gotta use distributive property for everything here. So negative 46. This side of the room. Y'all awake? Wake up. Wake up, wake up. Wake me up before you go. Now what?
Add the bottom.
Okay? Yep. And what do we get when we do it? Don't let them take all the answers. They're problem hogs over here. Y'all come on.
X.
1x? Negative 1x equals
0. No, 7, negative 9.
okay? Now, am I interested in negative x?
Negative 9.
Divide each side by negative 1. So x equals
X.
9. So that's half of my solution. Okay, you all find the other half. Choose the one you want to use. Choose what you want to use. Choose something different from somebody in the group with you. See if you get the same thing. Switched it up on you. Choose your equation. Choose your equation.
We're supposed to make up.
No. You got 2 original equations. Choose one of them. Substitute the value 9 for x.
Would you still keep the negative 2?
No, ma'am. No, ma'am. You go back to your original equation. Good question. Good question. When we are substituting, it's better to go back to your original equation. I see some pencils being thrown down. It's like y'all are throwing down the gauntlet. I got this problem. Y'all okay in the back? Let's see. This side of the room, what'd you get? 5. This side of the room, what'd you get? 5. Guess what? You're right. You're right. So what does this ordered pair, why are we finding this ordered pair? That's the intersection. If I graph these 2 lines, this is their intersection. This is their one solution. Okay? Good? All right. One more. One more. I'm going to see what you can do with one more, and then I'm going to tell you what I want you to do without me.
That's okay.
offset with the whole.
3x minus 5y.
Why would she find it?
All right, now. Huh? Now you have issues. That's funny. Do I have something here with opposite signs?
Lights.
The Y's. The Y's have opposite signs. So is there a way that I can make their coefficients be opposite? Do they have a least common multiple? 15. Is there a way that I can make both coefficients for this problem, for y, be opposites? How?
On the top one,
Do I want to multiply by negative?
No.
No. Why?
Because that would make the top one a negative.
Yeah, we want them opposite, so we don't want to multiply by negative. But we do want to multiply by 5. And we want to multiply the bottom by 3. Okay? Now we've done several working together. I want you to see if you can finish this problem using elimination together or in your groups. And before time runs out on us, I'm going to go ahead and put page 360 up here. Problems 7 through 18. I want you to choose 10. And I'm changing the directions. The directions say to use elimination. You have 3 tools to solve systems of equations now. You have graphing, you have substitution, you have elimination. I want you to choose the method on the 10 problems that you choose that you like the best. See if you can make it work for you. See if one might work better in a certain situation than the other. Okay, but you choose 10.
So it's homework.
Ma'am?
So it's homework.
Yes, ma'am, that will be your homework. How we doing? Doing okay? I'm going to do a vocabulary check in just a second. Yeah, you've got till close of business today to get your vocabulary terms to me. Your makeup work? Yeah, you can get your makeup work to me today, tomorrow. Just hang on to it for right now since we're rolling. Okay, what do we get when we multiply the top equation? Tell me what we get. Anybody? Ma'am? 20x plus 15y equals 40. And the bottom equation?
9x minus 15y equals negative 69.
Okay, if you have not gotten that far, that helps you out a little bit. Okay, tell me what you get in your process of eliminating the variable y. What do we get? Next step.
9x.
Okay, and then what? Divide both sides by 29. And x equals -1, very good. I'm gonna go ahead and tell you what you should be getting for y. For time's sake, you should get, what? Who got it?
I got 4.
You got 4, you got the right thing. Good job. All right. Any other questions or comments? Now, I want you to be preparing for a test next week, the 11th. Keep that in the back of your mind. Date is subject to change depending on if I think you're ready or not. We're going to be graphing systems of equations and finding a solution if there is one. We will be solving system of equations by substitution or elimination, finding a solution if there is